Hey guys, so in this video we are going to review how to write a quadratic in vertex form. And to start off, I want to make sure that we remember what vertex form looks like. Vertex form of a quadratic is written as ax minus h squared plus k. And remember, h and k are the vertex. Okay, so that tells us the vertex of that quadratic. And if we're being asked to write it in vertex form, then it must have been given to us in standard form. Remember, that is ax squared plus bx plus c. So these two a values are the exact same. It's telling us how that quadratic was stretched or compressed. And if a was negative, it would tell us if the quadratic had a reflection to the graph. So if we're in the standard form, how am I going to find h and k? Those are not the same thing as b and c. Okay? And what we know is we know in standard form how to find the vertex. And we find that x value of the vertex as negative b over 2a. So let's think about it like this. If we're trying to find h and k, h is going to be equal to negative b over 2a. That's that x value of the vertex, right? And we remember when we find that x value of the vertex, we simply plug that x value back in to our original equation to find k. And that's how we can write our quadratic in vertex form. So let's start our first example. Our first example, we have 2x squared minus 5x plus 12. Okay, and so remember, h is going to be negative b over 2a, the x value of the vertex. So in this case, a is 2, b is negative 5, c is 12. We don't even really need to know that c. All right, so h is going to be negative b, so 5 over 2 times 2. That is 5 over 4. Now we take this 5 over 4, it's the x value, and so that means I need to plug it in. Let's plug it in to find our y value, and that's our k. So k, if we think about this in function notation, if we think of f of x being equal to this equation, we want to find f of 5 over 4. So I want to take 2, 5 over 4 being squared, minus 5 times 5/4 plus 12. And we just need to simplify this. So we have 2, 25 over 16 minus 25 over 4 plus 12. Take it slow. Don't mess up any of your signs or anything like that. Let's go ahead. We can think of this as like 2 over 1 and cross simplify here. So we end up with 1 times 25, so 25. 1 times 8, so 8 minus 25 over 4. Make that a little more clear. And plus 12. Now we need a common denominator. Think of this as like 12 over 1. And our common denominator between 8, 4, and 1 is going to be 8. So I can leave 25 over 8 alone. I need to multiply top and bottom of this fraction, numerator and denominator, by 2. So 50 over 8. Then plus, we know we're going to have it over 8, so we need 12 times 8. And 12 times 8 is going to give us 96. And so from here, we just need to take 25 minus 50 plus 96. See, that should give us 71. So we now know h to be this 5 over 4. We know that k is 71 over 8. And we know a is 2. So, vertex form, I'll just say y equals. We'll do it that way. We need a. We're just plugging in to the formula. X minus h, so minus 5 over 4 squared plus k, so plus 71 over 8. So again, negative b over 2a using this formula here, and then taking that value, plugging it into the equation that we were given, and then filling in our formula. How about y'all go ahead? I'm going to come to this next page over here, and y'all do the second example. Actually, let me come back here so y'all can see the process. How about that? So I'll do it in a different color. Kind of separated under here. Let's do example 2. Use the same process and find the vertex form. Rewrite it in vertex form. Negative 2x squared plus 8x plus 3. Write this quadratic in vertex form. I'll give you a few seconds to get going on that. Alright, so let's see how we did. Down here we have A is going to be negative 2, B is 8, and that C is 3. And so we need to find H and K. So H is that negative B over 2A. So negative 8 over 2 times negative 2. So negative 8 over negative 4, which is positive 2. And we're going to find K. Think of it like it's in function notation. We're trying to find f of 2. So negative 2 times 2 squared plus 8 times 2 plus 3. And I'm just going to show these steps here. Negative 2 times 4 plus 16 plus 3. And our final answer here for K should be 11. H being 2, K being 11, we can plug into our formula. And so vertex form of this quadratic would be A negative 2, parentheses x minus 2 squared plus 11. Now, one thing I want to show you is another way that we can actually get this quadratic in vertex form. And one of the ways we can do that is actually by using the process of completing the square. If we try to complete the square, we will actually be able to get this exact same vertex form. So what I'm going to do is let's go over to this next page, and I just want to show you this, show you how this works, and show you how we get the exact same answer as we did in example 2. So we started off with the quadratic negative 2x squared plus 8x plus 3. And remember, vertex form that we got was negative 2 x minus 2 squared plus 11. So we're hoping we get that same answer, right? So what we're going to do is we're going to put parentheses around the x terms. Okay, these are the two terms I'm looking at. Remember, when we complete the square, we don't want a to be anything but 1. I need a to be 1, so I need to factor out this negative 2 from just this area in parentheses. So we're going to factor out a negative 2 from that, leaving me with just x squared, and then minus 4x. And then we still have this plus 3 on the end. Okay, and so remember, factoring it out is the opposite of distributing. So it's almost like I divided each of those coefficients by negative 2. It's how I found that x squared minus 4x. What I want to do now is I want to create that perfect square trinomial inside the parentheses. So I want to take, I'll use a different color here. b divided by 2 squared. And in that case, it is negative 4 divided by 2 squared, negative 2 squared, which is 4. So if I were to add 4 inside this parentheses, I would have created a perfect square trinomial. So let's see what happens when we do that. We have this negative 2, x squared minus 4x plus 4, and then this plus 3. Here's the thing, is how was I able to just add this plus 4 in there because I wanted to? And the answer is we actually can't just put in this plus 4. We've changed the value of this problem. And we haven't actually just added 4. If we were to distribute this negative 2 in, that's actually negative 8, isn't it? And so we have changed this expression by negative 8. We need to cancel that out. We need to zero that out because I cannot just change the value of the expression. So if I've brought in this negative 8 to zero that out, I need to add 8. Now we have negative 2. Let's factor out this perfect square trinomial, create our binomial squared. Remember our process for completing the square? Our little trick was to use this negative 2. That's how it would always work. X minus 2 squared, and then 3 plus 8 is 11. And those are the exact same thing. So we can find vertex form by using the process of completing the square as well. What I'd actually really like for y'all to do is I want y'all to try one. Try this. So we're going to do example 3 over here. Oh, let's see, where did it go? Here, we'll just go to the... We'll have you do example 3 right here. Okay, so think about that idea, that process. I'll rewrite the example over here since it's gone away because I want y'all to be able to look at that. But I want you to try to write this in vertex form using the process of completing the square. So the one I want you to do, I want you to do x squared plus 2x plus 5. And here, a is actually already 1, so you don't have to worry about that part. You don't have to worry about factoring anything out. But like I said, try to write this in vertex form. I'm going to rewrite your example over here really quick as you work that so you can follow along and see if you get that process. All right, let's see how we did. So remember, we want to put parentheses around the x terms. A is already 1, so we don't have to factor anything out. We can go ahead and do b divided by 2 squared, which in this case is just 1 squared, so 1. So I'm going to have this x squared plus 2x plus 1. Now I need to figure out how am I going to zero that out? Because I can't just add 1. And it is just 1 because there's no a value out here. A is just 1. 1 times 1 is 1. So I need to come out here and subtract 1. Since I added the 1 here. Remember, we want to zero it out. So you actually do the opposite sign there. We've created our perfect square trinomial. So we want to make that binomial squared. Rewrite it as a binomial squared. So that's going to be x plus 1 squared. And then the plus 5 minus 1, so plus 4. We can write it as y equals, make it into an equation. And here is x squared plus 2x plus 5 written in vertex form using completing the square. And you'll notice that actually when it's a case like this, it's a little bit less work. And it's really neat how it relies on this process of completing the square instead.